We are continuing on with the procedure exercises from TUT 10. There's still one left, number 3. It says, find the horizontal and vertical asymptotes of the given curve and use them together with concavity and intervals of increase and decrease to sketch the curve. Okay, well, the first thing that we can see just by looking at our equation is we definitely know that the domain is going to be from minus infinity up to minus 1, not included, and then from minus 1 up to infinity, because minus 1 can't be included because then our denominator will be 0. So let's just start off by writing that down. So the domain is from negative infinity to minus 1, not included. And it's also from minus 1 up to infinity. All right. So that's the first one. Let's now look at our asymptotes. So I'm going to look at my horizontal asymptotes first. And what I'm going to do is I'm going to look at the limit as x approaches plus or minus infinity of my function. Then what I'm going to do is I'm going to divide the numerator and denominator by the greatest power in the denominator, which is just x to the 1. So I'm going to have 1 over x minus x over x, which is 1, over 1 over x plus x over x, which is 1. And don't forget your limit in front. Right. So now, if x approaches plus or minus infinity, 1 over x, what's going to happen? It's going to go to 0. So we're going to have 0 minus 1 over 0 plus 1, which gives us minus 1. So y equals minus 1 is a horizontal asymptote. Next, let's now look at our vertical asymptotes. So, as we said before, minus 1 is not included in the domain of this function because then we have our denominator equal to 0 and we can't have that. So, for the vertical asymptote, I'm going to say x equals minus 1 is a vertical asymptote. And then we can also look at what happens to the function as it approaches minus 1 from the left and minus 1 from the right. And you can do that by taking the limit as x approaches minus 1 from the left of 1 minus x over 1 plus x. And you'll see that you get negative infinity. You can also look at the limit as x approaches minus 1 from the right of 1 minus x over x, 1 plus x, and you'll see you'll get infinity. Since in the first case, the limit will be 2 over a number infinitely close to 0, but it is a negative number. So we have a positive divided by a negative. That's why it's negative infinity. And in our second case, we have 2 divided by a number infinitely close to 0, but it's a positive number. So it's a positive divided by a positive. Next step is going to be to look at where the function increases or decreases. And to look at that, we have to look at our first derivative. So I'm going to take my function y equals 1 minus x over 1 plus x, and I'm going to work out the first derivative. So y's derivative is going to be, so I have the bottom multiplied by the derivative of the top minus the top multiplied by the derivative of the bottom, or over the bottom squared. This I can simplify, and I'm going to have minus 1 minus x minus 1 and then plus x over 1 plus x squared, which we can write as minus 2 over 1 plus x squared. So what can we say about this? Well, we see we have a negative number in our numerator, and the value in the denominator will always be positive. So we have a negative divided by a positive. So we can see that our first derivative is less than 0. It's a negative number for x not equal to what value? We can't have it be equal to minus 1, because then we have 0 in our denominator. For all other values, the first derivative is less than 1. It's less than 0. So what we can say from this is that from minus infinity to minus 1 and from minus 1 to infinity, we have intervals of decrease since our first derivative is less than 0. So we're going to use this later when we sketch our curve. The final thing we want to look at is our second derivative to determine the concavity of the curve. As they tell us, we have to determine the concavity as well. So let's look at our second derivative now. So our second derivative will be the derivative of the first derivative. So I'm going to take the derivative of that. So it's going to be the bottom multiplied by the derivative of the top, which is just 0. Then I have minus the top multiplied by the derivative of the bottom, which is 2 times 1 plus x. And then I have that all divided by the bottom squared. So what I get here is I have in my numerator 4 multiplied by 1 plus x, and in my denominator 1 plus x to the 4. So this becomes 4 over 1 plus x cubed. So what we can see here is our numerator is always positive. Our denominator, however, is going to be negative if x is less than minus 1 and positive if x is greater than minus 1. So our second derivative is going to be negative for x less than minus 1, and our second derivative is going to be positive for x greater than minus 1. This means that the curve is concave down on the interval from negative infinity to minus 1, and the curve is concave up on negative infinity on minus 1 to infinity. So what we're going to do now is we're going to use all of our information that we've worked out, and we are going to sketch our curve. So I'm firstly going to start off simply by drawing in my asymptotes. So I said that I have a horizontal asymptote when y equals minus 1. And I also said I have a vertical asymptote when x equals minus 1. So let's draw those two in. I'm going to draw them in red. So this is my first one. This is when x equals minus 1. And this is my second one. That is when y equals minus 1. Then we also showed that we have an interval of decrease from negative infinity to negative 1, and also from negative 1 to infinity. Another thing we said is that when x approaches minus 1 from the left, we have our curve approaching negative infinity. If x approaches minus 1 from the right, we have our curve approaching positive infinity. So, using all of that information, and also using the fact that the curve is concave down from minus infinity to minus 1 and concave up from minus 1 to infinity, our curve will look something like this. You can also find your x and y intercepts simply by putting x equal to 0 or y equal to 0, as we usually do. This is the end of the procedure exercises. In the next video, we'll be looking at the principal exercises.